we're doing those perfect squares, right? So we had 181, and we're dividing it by 2, and we said that's going to be about the square root of 90.5. Would I be okay if you just said the square root of 90 here? Approximately. Okay, we're writing this down, right? You didn't have this done? This would be a perfect time to have this done. Don't need devices, but you're writing this right here. You didn't have it, right? Okay, so you're going to write this down. Because it seems like I'm doing it just because I think it's really cool to do the work up here for you, but then you'd have this done, right? So if I'm checking it, you'll have this completed, right? So this is at 9.5. 94 has to be bigger than that, right? So now I'm going to approximate it, right? I'm not going to finish this one for you. The next one says use your calculator. So now you're putting in your calculator the square root of 94, and you're using it, and it says find the length of the side round to the nearest tenth. But this is using your calculator. And then it asks you if it'll fit. Oh yeah, lunchtime. 26 says, oh, if x squared equals 256. What do you have to do to both sides to get x? It doesn't say, so it says, what inverse operation? So what's the opposite of squaring? It is to find the square root. This is the opposite, the inverse. These two are inverses, right? And since some of you now know 256, what is the square root? That's one of your perfect squares, right? It is 16, right? So x should equal 16 and negative 16, right? It has to have the 2, right? So this is where that memorizing. So on the test and on the quiz, I'll give you something like the square root of 256, and that's where I'm looking at you doing 16, right? Just like today's homework where you're looking at that. This one says, well, what is the cube root of something that equals 4? So to find this, what's the inverse of finding the cube root? We're going to do what? Cube it. Right? We're going to take 4 to the third power, which just means 4 times 4 times 4, which would give us 64. 8 squared and 4 cubed, same answer. 8 squared, 4 cubed, same thing. Oh, 64. Okay? So, we're still not using your calculators, and you're going to turn in your notes now. We are not going to do all of A4 because I don't like all of it. I don't think all of it's appropriate for us right now. So, here's the key thing. We are going to be looking at numbers going from general to specific. Okay? General to specific. And when we talk about numbers, the most general type of number that we are going to talk about are real numbers. Real numbers, I want you to write down, is every number on the number line. Real numbers are every number on the number line. And then we're going to break it into 2 categories that you see that I've written on the board up here. The first one is irrational. Not like when your parents say, you're so irrational, I can't believe you're doing that. Not that kind of irrational. Okay? Irrational. And then we're going to talk about rational, like, oh, that was such a rational thing that you did today, right? So that's a lot of times, okay? Not the math meaning. The math meaning for rational just means you can write it as a fraction. It just means you can write it as a fraction. Any number written as a fraction. And they get more specific, the rational. They have more specific kinds of names. They have special names. But today, the only thing, and on our assessment, the main thing, is you need to know rational or irrational. So any number written as a fraction. Can 4 be written as a fraction? 4 over rational. Can 0.3 be written as a fraction? Anyone know what it is? 1/3. It's rational. 7.25, could that be written as a fraction? 7 1/4, right? 0.25. If the decimal ends or it repeats, it's rational. So what in the heck are we talking about irrational? Can never be written as a fraction. And the key thing that we a lot of times want to think with this, as a decimal, it never repeats and it never ends. Never repeats, never ends, yeah?
Wait, then why would 1/3 work? Because it's real decimals.
It repeats, it's over here. It can repeat to be rational. It just can't be irrational, right? So 1/3, 0.3 repeating can't be irrational. It's actually rational. Okay, good question. So these are two separate categories, right? Square root 4. Is it rational? Can we write it as a fraction? What's the square root of 4 equal to? You guys know this. 2. Can 2 be written as a fraction? Yeah, 2/1. Is square root of 4 rational? Yeah. How about the square root of 2? Oh, square root of 2 is over here, right? Square root of 2 is over here. Square root of 3? No. That's going to be irrational, right? Anyone that's not a what? A square root of anything that's not a what? Perfect square. Those are going to be irrationals, right? If you find the square root of any perfect square, always rational. Yes. Nice, nice. Okay. So that's going to be important as we move forward with this. Now, there's other special names below rational, and if you, we already did that. If you turn to this page, that bottom page in your notes, do you see this under rational? They have integers. What's different from the integers to the whole numbers? What's different? Integers have negatives. Whole numbers, that's like 0, 1, 2, 3, okay? When I think of this, this is the most general category, right? This is the most general category. Then it gets more specific in integers and whole numbers. This is the most specific, okay? This is my most specific, right? Every whole number is an integer. Every whole number is a rational number. Every whole number is on the number line, right? All of the specific things belong to the categories above it, okay? But not every rational number is a whole number, right? 1/3 is not a whole number. It's a fraction. It's up here, right? 7.296349283 is rational. It stops after that last number that I read, right? It's rational, but it's not an integer and it's not here, okay? So, if we are looking at this, it says to write any rational number as a decimal, we can divide the numerator and denominator. We get terminating decimals, right? We saw those terminating decimals. We have repeating decimals, okay? Right now, what I want you to do is 0.4. Also read as 4 what? What's the place value? 4/10. So if you have a decimal and the place value 4/10, I would give you full credit for putting that down. This is in your notes, okay? 4/10. I give you full credit for that, right? Could you simplify it?
Yes. Too fast.
Both answers are correct. You don't like simplified? It's a hard thing for me to give up this year, but both answers are correct. Okay? This one, -1.97. -1 and 97 what?
Hundredths.
97. You guys have done this, right?
Yeah.
You're done. You leave it, right? 0.27. 0 and 27 what?
Hundredths.
There you go. 27. Okay. All terminating Decimals, are they rational? Can you write every terminating decimal as a fraction? Are they rational?
Yeah.
Yes.
Yes.
Why? You can write it as a fraction.
Yes, right fraction.
Okay? I'm going to tell you which problems you're going to do in your homework now. Okay? So we are not going to do this repeating one in your notes. We're going to save that for tomorrow. It's a Good Friday topic, right?
Yeah.
Doesn't it look like a Good Friday topic?
That looks
All right, so here's what you are doing. Do not cross any off at this point. You are only doing number 1, number 4. These are terminating decimals, right? 1, 4. You're going to do all of this column 7 to 11. So we're starting tonight with 1, 2, 7 to, oh, we're going to do 7 to 21. We're going to do all of those, okay? And I want you to look at 7 to 21 because it says, find the most specific. I actually want you to tell me all the ones. So, you look at this number right here and with those dots behind it, what is that telling you? That it continues on and on and on? Okay, so can it be a whole number?
Yeah, no.
No, 0, 1, 2, 3. Can it be an integer?
No.
Negative with a no. Terminating decimal?
Yes.
It doesn't end. Terminate means end. Does it end? No.
repeating.
Does it repeat?
Yes, it does.
2, 4, 5, 2, 4, 5, 2, 4, 5, right?
Yeah.
So we put repeating. Could we write a repeating decimal as a fraction? Well, tomorrow you're going to see that yes, we can. Okay? But you can just go that. Right? So you're going to put down, check those answers in the back. So only 1, 2, and 7 to 21. Okay? Does that make sense what you're doing?
Yes.
Start now. Leave it open. You have 4 minutes. Start now. I'm going to pick up your baggie that's on your desk.